Alright, and now we are looking at series parallel circuits, open faults. We're going to actually look at two separate ones. This first video is just going to discuss opens in the series portion of the circuit, and the next video will discuss opens in the parallel portion of the circuit. So this one is actually a pretty simple one, and it won't take us very long. When you have an open in the series portion of your parallel circuit, in this case we have opened R1, then you lose your path for current flow, and so all current flow stops in the circuit. And you can see here all the lines are going away that represent both our series and our parallel current. And so now that we no longer have any current flow in our circuit, we're going to take a real quick look at all of the numbers that we see in our circuit. So we'll start with resistance. Yes, we still have our branch 1 and branch 2, and they still have 2K ohm resistance, and neither one of them are faulted, so we have a resistive equivalent of 1K ohms. However, our series resistor now has a maximum resistance. So when we look to put together total resistance, we can add our 1K ohm to maximum, and we end up, of course, with the total of maximum or infinite, or what is creating our open. Alright, and then, of course, we move right over into current after resistance. We use Ohm's law for that, and we already know that there is no current flow. We just looked at that with our arrows, and since there is no current flow, our current is of course going from 4 milliamps to 0 amps. So we have no current and maximum resistance. Now we look at our voltage drops. We'll start with R1. R1's a fairly easy one. We know that across our open component, we, of course, will not see 8 volts like we did originally. Now we will see our applied voltage, which is 12 volts. And that, of course, is due to meter loading like we've talked about before. And it's easy enough to see that one side of R1 is tied to the positive side of our battery, and the other side of R1 is tied to the negative side of our battery. So if we were to read across those, we would see our applied voltage. Now, we look at our branch resistors out there, our REQ, and we know that there is no current. So our original REQ is 4 volts, and now, of course, it is 0 volts, because no matter that we do have functioning resistors out there, if we had current flow, we don't have any current, so voltage is resistance times current. And with no current, we end up with a 0 volt drop for our voltage. And similarly, it's no surprise that if we have no voltage out on our branches, we also, of course, have no current. So we're not even going to look at branch current. We already know there's no current out there. Now, again, we look at our voltage drops, and we know that the voltage for branch 1, the voltage for branch 2 are both the same. And they are, of course, the 0 volts that we got for our voltage out on our parallel, because it is our series component that is open, and we see applied voltage across our series resistor. So if we add our 0 volts and our 12 volts, we still come out to our applied voltage, which is 12 volts. And that is it for an open in a series component. Very simple concepts to grasp. You should be really familiar with them. We are going to look next at opens in the parallel portion, which can be a little bit trickier.